This is R.D. Sharma solution, class 12, chapter 11. Differentiation exercise is 11.8. Differentiate x square with respect to x cube. So what we have to do here is dx square divided by dx cube. This is what you have to think about. So what we'll do here is u is x square. We assume x square to be u and assume x cube as v. So du by dx we'll find out, dv by dx we'll find out, and then see u is this and v is this. So u by v, du by dv we have to find out, du by dv. This is what is to be done. Du by dx is 2x, dv by dx is 3x square. Now just divide them. This is 1 and this is 2. So we have to divide these. Du by dx divided by dv by dx, and that corresponds to 2x divided by 3x square, and that is 2 by 3x. So this is going to be your way of solving all other questions like this. Differentiate log 1 plus x square with respect to tan inverse x. So d of this divided by d of this. This has to be done. The questions which are upcoming, they will have a range also. They'll give the boundary or limitation or range, you can say. I will discuss about that. So log 1 plus x square, d of this divided by d of this, tan inverse x. So u is what? Log 1 plus x square. And v is what? Tan inverse x. So du by dx is going to be 1 by 1 plus x square, and differentiation of 1 plus x square is going to be 2x. Differentiation of this is dv by dx with respect to x is tan inverse x is 1 by 1 plus x square. So du by dx and dv by dx we have to do. So let us divide these two. 1 plus x square, 1 plus x square you can cancel. This is 2x. So it is going to be 2x. Okay. Differentiate log x raise x with respect to log x. So what we will do here is, if we do it directly, there will be some more effort. So the best way is to take the log. That is, see, u is equal to log x raise x. So log u is going to be equal to x log of log x. That is, we have to take the log. So 1 by u du by dx will be 1 by u du by dx is equal to, now x log x is 1 log x differentiation we have to do. So 1 by log x, and differentiation of log x is 1 by x plus now log x and differentiation of x, that is going to be equal to 1. So this x gets cancelled. So 1 by log x plus log x and 1 by u has to go on the right. So we take log x raise x. This is 1 by log x plus log f log x. So this you can solve more if you want. But we'll first see this v. v is equal to log x dv by dx. Log x is 1 by x. Differentiation is 1 by x. So du by dx divided by dv by dx we have to find out. So you get du by dv. That's what is expected. Okay, so let us divide it by 1 by x. Okay. So let us solve this first and then we'll divide it by 1 by x. So log x to the power x. This is 1 plus, this goes here, log x into log of log x, and divided by log x it will be, and there is 1 x also, and since it is 1 by x, x goes up. X goes up, 1 by x we divide, so x goes up. And what about log x to the power x and log x? When it goes up, it will be log x to the power minus 1. Log x to the power x is already there. So log x to the power x and log x to the power minus 1, it goes log x to the power x minus 1. So you get x log x to the power x minus 1. Here we have 1 plus log x into log of log x. Alright. So that is going to be your final du by dv. Differentiating this with respect to that. Now this kind of questions, we have x belongs to 0 to 1. So u is equal to sine inverse 1 minus x square. V is cos inverse x. So we will put x as something so that we can simplify this, because x is also given to be 0, 1 in between. Okay. So if we do dv by dx, cos inverse x will be what? Minus 1 by, because we know the differentiation of sine inverse theta and cos inverse theta. So cos inverse x will be negative 1 by under root 1 minus x square. When you do this x, when we put x as cos theta, u will be equal to sine inverse under root 1 minus cos square theta. So 1 minus cos square theta is sine square theta, under root of sine square theta will be sine theta. So you will have sine inverse sine theta. When you cancel this, you cannot cancel sine and sine inverse just like that. It has to be between certain range which we have already discussed in our previous various discussions. Okay. So x belongs to 0 to 1, that is x is between 0 to 1. X we are putting as cos theta, so cos theta has to be between 0 and 1. So in order to find out theta, it will be cos inverse 0 and cos inverse 1. That is, you take cos inverse everywhere. So cos inverse 0, cos inverse of cos inverse of cos theta and cos inverse of 1. So you know already cos 0 is 1 and cos pi by 2 is 0. So when you take this, the range or the value in between the theta lies is pi by 2 and 0. So theta belongs to 0 to pi by 2, you can say like that. Okay. So if you cancel this, it has to be between minus pi by 2 and pi by 2. So it is properly in the range, 0 and pi by 2 comes in between. Alright. So this kind of cancellation sine and sine inverse is possible is in this case. So u is equal to theta now. What do you get from here? Theta? Theta will be cos inverse x. In this case, theta will be cos inverse x. So you can put theta as cos inverse x here. Du by dx will be cos inverse x will be minus 1 by under root 1 minus x square. Now if you see very closely, du by dx and dv by dx are exactly similar. They are same only. So if you divide them, you are going to get 1. That is 1 divided by 2 you have to do. And since visually I can see they both are same, so it's 1. You have to divide them properly, show them to the examiner, and then it is 1. Now this sine or sine inverse cancellation, cos and cos inverse cancellation, this is only possible when there is certain range. Okay, it cannot be just done just like that. Here you will see there is a difference. The previous question, the content was in the range, so we just cancel one sine and sine inverse. Here when it is not in the range, then what we have to do, that is the representation of this question. That this question will show you like that. Okay. Okay, now let us see this. Sine inverse u is sine inverse under root 1 minus x square, v is cos inverse x. So du by dx we have to do and dv by dx we have to do, and then we divide them. So dv by dx, we have v as cos inverse x. dv by dx is minus 1 divided by under root 1 minus x square. This is very clear. Coming to this first part, which is the u. We are out of the range. You will just see that. We are going out of it. So you have u as sine inverse under root 1 minus x square. Now x we are putting it as cos theta. Just to simplify this. So we will just put it here. X is cos theta, so it will be sine inverse under root 1 minus cos square theta. So sine inverse 1 minus cos square theta is sine square theta. Under root of sine square theta is going to be sine theta. Now sin inverse sin theta, so you can cancel this and the theta will be, the result theta is actually equal to cos inverse x, and you have to differentiate cos inverse x. That is what we have done in the previous question also. But now you will see the range, because if the question is saying it is from -1 to 0, x is between like that. So we have to check also, and then this will be theta or pi minus theta, the result will be according to that. So x is between -1 and 0 in this case. So basically x we have to put as cos theta. So cos theta is between -1 and 0. So this is between pi and pi by 2. If you take cos inverse, it will be pi and pi by 2. So theta has to be between what? It has to be between negative pi by 2 and pi by 2, which we have already seen, which is out of this range. So you cannot put this as, when you cut sine and sine inverse, you cannot put it as theta. You have to put it as pi minus theta. That is the whole idea. In trigonometry, when we cancel this inverse, then you have to see the range also. So it will be pi minus theta. From here, x is equal to cos theta, theta will be equal to cos inverse x. So pi minus cos inverse x it will be. Okay. Now you'll see there will be no difference as such. But the answer will be different. When you take du by dx, what are you going to get? Pi will be 0. Minus will remain like that. Cos inverse x will be what? Minus 1 by under root 1 minus x square. Minus minus gets cancelled. So it will be 1 by under root 1 minus x square. So now dv by dx, du by dx, both you have. Now divide them as we have been doing in the previous questions. Divide them, this gets cancelled. Only -1 will remain. -1 will be answer. Unlike the previous question which gave you 1 as the answer. Right? So the concept is like this. You cannot just cancel things. In competition it is very important. Because this is what is asked. We have to differentiate sin inverse 4x under root 1 minus 4x square with respect to under root 1 minus 4x square. And x is between these two. Alright. So u will take as the first one, v will take as the second one. Du by dx, dv by dx will divide. But the range is also given. X belongs to certain boundary, certain range. Now when you see this question, you see there is 4x square, right? So we will take u as what? Sin inverse 4x under root 1 minus 4x square. So we see that this 4x, it can be written as 2 into 2x. And 4x square can be written as 2x square. So u will be equal to sin. 2x will put as what? 2x will put it as cos theta. 2x as cos theta. So when you put 2x as cos theta, when you replace it there, you will get sin inverse 2 into cos theta. And this again 2x is cos theta. So you will get 1 minus cos square theta. 1 minus cos square theta is sin square theta. So under root sin square theta is sin theta. So you can write sin theta here. But 2 sin theta cos theta is again a formula. It is sin 2 theta. Sin 2 theta is 2 sin theta cos theta. So sin inverse sin 2 theta. Now you need to cancel these two. You need to cancel sin inverse and sin. So 2 theta should come. But before doing that, we have to see the periphery. We have to see the boundary. So x is between negative 1 by 2 root 2 and between 1 by 2 root 2. So this is the range being given, which is the range being provided. Alright. There is a misprint there, but don't worry, you know what we are doing. We have to see 2x here, because 2x is cos theta. So multiply this whole by 2. 2x is between minus 1 by root 2 and it is between 1 by root 2. 2x, it is 2x, not x, it is 2x. 2x between these two. And what is 2x? It is nothing but cos theta. So you can replace 2x by cos theta is in this inequality. And cos theta is between negative 1 by root 2 and 1 by root 2. When you do the cos inverse, take the cos inverse. What do you get? Cos inverse. So cos inverse of cos theta, that is theta. And cos inverse minus 1 by root 2 and cos inverse 1 by root 2. You already know that. If you have done trigonometry properly, you know what does it mean. So cos inverse minus 1 by root 2 is 3 pi by 4. It is just pi minus pi by 4 kind of thing. So you have 3 pi by 4, and then on the right you have pi by 4. Add sugar to coffee, you know already that. Pi minus pi by 4 is going to be negative only. So sine and sine inverse and sine inverse. When you cancel this, it has to be between certain range, as I told you. And since 3 pi by 4 and pi by 4 is not in the range, okay, that is not in the range, so you cannot just cancel these two. The answer should not come as 2 theta when you cancel sine and sine inverse. It will come as pi minus 2 theta. So when you cancel this, it has to be equal to pi minus 2 theta as the previous question. So you will write it as pi minus 2 theta. Alright. And when you put this as pi minus 2 theta, theta will be what? 2x is cos theta. So theta will be cos inverse 2x. So in place of 2x, you can write cos theta. Cos theta is actually cos inverse 2x. So when you do 2 theta, it will be 2 cos inverse x. So pi minus 2 cos inverse 2x it will be. Okay, now you have to differentiate this. Pi minus 2 cos inverse 2x. So I will just clear this, and then I'll write again and do the following things. Okay. So you have pi minus 2 cos inverse 2x. 2x is cos theta, as you have already seen. So du by dx is minus pi 0 minus 2 cos inverse 2x. So it will be minus 1 by under root 1 minus 2x square. Alright. So this is going to be minus minus is plus. So 4 by under root 1 minus 4x square. This is only du by dx. Remember? V is equal to under root 1 minus 4x square. So it will be 1 by twice of anything of root is 1 by twice of under root of that. So 1 by twice of under root of that. If you assume it to be just root t, differentiation will be 1 by twice of under root t. 1 by twice of under root t. There is no negative, okay? There is a mistake, there is no negative. And 1 minus 4x square differentiation is 1 is 0. And minus 4x square is 2x. So this you can write here. There is 1 by twice, okay. Root x is 1 by twice of under root x. So twice of under root 1 minus 4x square, 1 minus 4x square differentiation also we have to do. I am just showing you how to do this because it is under root of this. And 1 minus 4x square, as I already told you, it is going to be minus 4, this 2 into minus 4 dot 2x. Now 2 gets cancelled and there will be a negative. There is no, see, minus 4x will be there. One negative which I have placed is by mistake. So there is a negative remaining, please remember. Du by dx divided by dv by dx. Now put it here. Minus 4x by under root 1 minus 4x square. It is negative, please remember. Minus 4x by under root 1 minus 4x square. Okay. Just cancel these two out. You will get 1 minus 1 by x. So there is a negative also. Minus 1 by x. And that is going to be your answer. So this is how we have to follow all the other questions like this. Not a very big exercise, but surely important exercise. Alright. So 1 minus, this is positive, minus minus positive, and this negative has come from here. So there is only one negative, that is why we have a negative 1 by x. Please, I just made a correction here. Okay. Now this type of question we have already done, and the way is to put the 2x is cos theta. It was minus 1 by 2 root 2 to 1 by 2 root 2, and I hope that you will be able to do this. Okay, the answer there was negative 1 by x. Here it is 1 by x. The procedure is exactly same. Okay, now coming to this question. See, all these questions will tell you why trigonometry and trigonometric equations and questions related to that are very important. Because here we are going to directly use that thing. Okay, those who want to do themselves, I have presented the answer. And those who want to understand, you will take this, we will take this, and du by dv we have to find out. And the boundary or the periphery is between -1 and 1. So u is this one. So this u is equal to tan inverse under root 1 plus x square minus 1 divided by x. Now here x will take it as tan theta. And when you put x as tan theta, you have to check the boundary also. Because x is tan theta, x is between -1 and 1. So tan theta has to be between -1 and 1. This is what question is asking. So tan theta has to be between -1 and 1. Now you can just take the tan inverse of all the values. So this is going to be negative pi by 4. This is theta and this is pi by 4. So what x we have to put, because when we put this x, you will see that it will come down to a very easy solution. 1 plus tan square minus 1 divided by tan theta. So this tan you have to put it here. I am writing as t for tan theta because this is an intermediary process. So 1 plus tan square theta is sec square theta. And under root of sec square theta is going to be sec theta. So final will be tan inverse sec theta minus 1 divided by tan theta. Sec theta is 1 by cos theta. So 1 by cos theta minus 1 and divided by sin theta by cos theta. So 1 minus cos theta by cos theta divided by sin theta by cos theta. Cos you can cancel. 1 minus cos theta by sin theta it will be. So it will be tan inverse 1 minus cos theta divided by sin theta. So 1 minus cos theta is what? See, in many questions we have already done this. So it is going to be 2 sin square theta by 2. 1 minus cos theta. And sin theta is 2 sin theta by 2 cos theta by 2. 2 cancel, 1 sin will cancel, you will get tan theta by 2, you will get tan theta by 2 and tan inverse tan theta by 2 and tan inverse need to be cancelled and this is theta by 2. So that is what I was talking to you about this. So you have to take theta by 2 in order to check the boundary. So theta by 2 is going to be what? It's negative pi by 8 and here also it will be pi by 8. And that is going to be inside your periphery, which is actually when you cancel tan and tan inverse, it has to be between negative pi by 2 and pi by 2, which is actually this pi minus pi by 8 and pi by 8 is inside that. So no problem with that. Alright. So theta by 2, theta you already know from here. If x is tan theta, theta is going to be tan inverse x. So just write tan inverse x here divided by 2. And this is u. So du by dx you have to find out. The tan inverse is 1 by 1 plus x square. And this 2 is in the denominator. Alright. So du by dx. This I am going to use in a short while. Okay. Let us come down to this sin inverse 2x by 1 plus x square. So v is equal to sin inverse 2x divided by 1 plus x square. Here also x you can put it as tan theta. And same kind of boundary or periphery checking you have to do. Alright, so you have x, this is equal to sin inverse 2 tan theta divided by 1 plus tan square theta. See, 2 tan theta divided by 1 plus tan square theta is sin 2 theta. So sin inverse sin 2 theta, you can cancel these, sin and sin inverse 2 theta will come. So this, now when you check this, you have already checked for theta. You already checked for theta by 2. Now what you have to do, you have to check for 2 theta. So theta was between minus pi by 4 and pi by 4 if you remember. Same thing you have to do twice, okay? One for theta by 2, one for 2 theta, because these are two different entities. So this you already done. I already showed you that. But now you have to check for 2 theta. So multiply 2 everywhere. It will be negative pi by 2 here, pi by 2. And this is 2 theta. So it is between the periphery, which is acceptable to us because we can cancel sin and sin inverse now. It has to be between minus pi by 2 and pi by 2. So what do you get? 2 into theta. Theta is tan inverse x. So dv by dx is equal to 2 tan inverse x is 1 by 1 plus x square. Now remember, if you remember, du by dx we have already computed. And that has come already as this one only. 1 by 2, 1 plus x square. So now just du by dx we have to do. So we have to do du by dx divided by dv by dx. that is 1 by twice of 1 plus x square divided by twice 2 into 1 by divided by 1 plus x square. So this gets cancelled. 2 into 2 is 4 in the denominator. So what do you get? This gets cancelled. 2 into 2 is 4. Finally you get 1 by 4, that is du by dx. Okay. Differentiate this term with respect to this term. Again, lot of trigonometry, lot of trigonometric equations. I would suggest those who are not following this to go back, learn all the trigonometric formula again and again, because we are just simply using it here. So u is sine inverse 2x under root 1 minus x square in this case. So x is equal to sine theta here. So it will be sine inverse 2 sine theta, because x is sine theta. So under root 1 minus sine square theta, sine square 2 sine theta. Under root 1 minus sine square theta, 1 minus sine square theta is cos square theta. Under root cos square theta is cos theta. So you get 2 sine theta cos theta. 2 sine theta cos theta is sine 2 theta. This is sine 2 theta. So this 2 theta has to be in between what? 0 and 1 by root 2. But this is not 2 theta. This is first you have to do is x is between 0 and 1 by root 2. Then you have to put x as sine theta. Then you take the inverse. And then finally you have to check for twice of that theta. I hope you will be able to do it. Okay. So I'm not doing it. I will just keep it for you because we have done it already many times. So let us come to the next step. U equals 2 theta. 2 into theta is sine inverse x. So du by dx is 2 into sine inverse x is simply 1 by under root 1 minus x square. This differentiation we already know. So 2 into 1 by under root 1 minus x square it will be. This is du by dx simply. Next step will be dv by dx. Okay, dv by dx, let us see what do we get. So this we are going to just use while we finally divide the two terms. Range for both the things. The first part and the second part, that is sine inverse and sec inverse. For both you have to check the boundary and show that okay, this is within the limits. Second one is v equals sec inverse 1 by under root 1 minus x square. Same thing here. In place of x, you can just put it as sine theta. So what do you get? Check. This is up to you. Now, v equals sec inverse 1 minus x square. 1 minus sine square theta is what? Cos square theta. Under root cos square theta is cos theta. And 1 by cos theta is sec theta. So you have sec inverse sec theta. But most of the time people just remember about sine, cos, tan. So the boundary checking has to be done on cos inverse. So the best way is to just invert it. It will be, this is exactly equal to cos inverse cos theta. Okay. Sec inverse sec theta is cos inverse cos theta. It's almost same. And this cos inverse boundary you already know from where to where it should belong. Okay. I hope you remember it. So you have to check for cos theta now here. Because whenever you cancel this cos and cos inverse, the boundary checking has to be done because you have put x as sine theta by yourself. X as sine theta nobody has asked you to do. So you have done it by yourself. So you have to show the examiner, okay, this is the boundary checking. So finally theta has come and it is within the boundary. I can tell you, if you just do it by yourself, you'll see that. Theta is sine inverse x from x equals sine theta. So dv by dx is going to be equal to 1 by under root 1 minus x square. So du by dx you know, dv by dx you know, and you can just divide these two. So du by dv, that will be your final result. So twice of under root 1 minus x square under root divided by 1 by under root 1 minus x square. This you can cancel, you get 2, and that is going to be your answer too. Okay, this is your final result. Okay, this question again, it's exactly similar to this one. There is no change, only the range is changed. 1 by root 2 to 1. The boundaries, see, the same question will give you different result if the boundary is different. Because if you don't think or don't worry about x belongs to 1 by root 2 comma 1, you will not be getting the right answer. Okay, this is very important. Same thing you have to do. And let me tell you, the boundary, the result will be inside your boundary or periphery. So don't worry about that. Alright. So it will be inside that. And same result will come, because the previous question also gave us the same result. Here also you are going to get the same result. Right. Cos x raise sin x raise cos x, and the result, because this in the previous 11.7 we have done this, 11.6 also to some extent we have done it, because those exercises where we used log to solve this differentiation. Here also u is equal to cos x to raise sin x, log u will be what? Sin x log cos x. And when you differentiate this, 1 by u du by dx is equal to, now you apply the product rule here. So sin x log cos x will be 1 by cos x. Cos x is minus sin x. Then plus log cos x here. Differentiation of sin x. Sin x differentiation will be cos x. Alright. So you have sin by cos as tan. And minus sign will be, just to make it simpler, we don't want anything in the denominator because that will complicate the thing. So better is to use this sin by cos as tan. So it will be tan x minus sin x. So minus sin x you can put in front, minus sin x tan x, and log cos x you can write first. So cos x log cos x. Otherwise it will be seen as log cos x. So 1 by u will go on the right. Write this, u is nothing but what? Cos x raised sin x. So du by dx is this one. We are going to employ this. We are going to use in the final result. Okay. So the next one is v equals sin x raised cos x. So log v will be equal to sin x and log sin x. This is 1 by v dv by dx. And cos x log sin x will be 1 by sin x will be cos x, plus log sin x cos x will be minus sin x. So write it as minus sin x. Now you can again use this. Okay, cos by sine, just take it as, because previously sin x by cos x we put it as, or took it as tan x, cos x by sin x as cot x. So cot x cos x minus sin x log sin x into log sin x. So log sin x, it will create confusion. So always take the sin x in front. So sin x log sin x. And we will go on the right. So here v will be sin x to the power cos x. Now du by dv we have to find out, so that you get du by dx divided by dv by dx. Okay. So let us divide these two. So we divide these two. So I'm just taking this and I'll just swap the position of the inner two terms so that we get a negative inside. So cos x raised sin x. Here you'll get cos x log cos x minus sin x tan x, and divided by this one, sin x raised cos x, and then we have cot x cos x minus sin x log sin x. Alright. So this is your answer. This is the same thing. So this is more like the previous questions we have already done. There is nothing of this sort. So we have sin inverse 2x by 1 plus x square, and we have to do it with respect to cos inverse 1 minus x square divided by 1 plus x square. Periphery is between 0 and 1. Please remember, in both these terms, we will put x as tan theta. X is tan theta. So theta will be equal to tan inverse x. Tan inverse x. Okay. So final result, we will just check between 0 and 1, and I hope you'll be able to do that. We have done in a lot of the questions in previous also and this also. So u is equal to sin inverse twice of tan theta divided by 1 plus tan square theta. And this we have done a lot of time. 2 tan theta by 1 plus tan square theta is nothing but sine 2 theta. So sine inverse sine 2 theta. This sine and sine inverse we can cancel. We'll just check. I'll just check it for you just to recall. Okay, what exactly this is. So theta is tan inverse x. U is du by dx is 2. Tan inverse x is 1 by 1 plus x square. This is du by dx. Now coming to v. V is equal to what? V is cos inverse 1 minus x. In place of x I am writing 10. So 1 minus tan square theta by 1 plus tan square theta. 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. So cos inverse cos 2 theta, you can cancel cos and converse. And then we can just see that only 2 theta will come. And theta is nothing but tan inverse x from here. And dv by dx is equal to 2 tan inverse x 1 by 1 plus x square. Okay, so whether you check or not, you'll see dv by dx and du by dx are exactly same. They both are 2 by 1 plus x square. Alright, so when you divide them, you'll get 1. This is your answer. So 2 theta, this theta, see, basically x has to be between 0 and 1. And this x is what? Tan theta. Tan theta has to be between 0 and 1. And when we take the tan inverse, it's going to be, so tan inverse you take this, and this is going to be between 0 and pi by 4 multiplied by 2. So you get 0 and pi by 2 as the boundary or the periphery. So 2 theta has to be between this. Okay? That is true also. So we have tan inverse, and inside this we have ax in both the u and v. So if you want to do by yourself, let me present you with the answer. And this is u and this is v. So du by dv we have to find out. U is this one, tan inverse 1 plus, now ax we'll call it as tan theta. So let us assume ax as tan theta. So theta will be equal to tan inverse ax. So what do you get here? Tan inverse 1 plus tan theta divided by 1 minus tan theta. So we know that tan pi by 4 is equal to 1 and tan 45 degree is equal to 1. So in place of 1 we can replace it by tan pi by 4. So here you have tan pi by 4 plus tan theta divided by 1 minus something into tan theta. What is that something? 1. Okay. So we can replace again this by tan pi by 4. 1 minus tan pi by 4 into tan theta. So this is called tan, because this is the formula of tan a plus b. So tan pi by 4 plus theta it is. And you have tan inverse here. You can cancel tan inverse. So you'll get pi by 4 plus theta. So u is equal to pi by 4 plus theta. And pi by 4 plus theta, what is theta? Tan inverse ax from here. So I'm replacing it now. Du by dx will be equal to pi by 4 is a constant, it will be 0. Tan inverse ax will be 1 by 1 plus ax whole square. So 1 plus ax whole square or a square x square. Then the differentiation of ax, which is going to give you a. So a divided by 1 plus a square x square. Okay. Now v. So v is under root 1 plus a square x square. So ax whole square it is. So dv by dx we have to do. Okay. So if you want to put ax as something, you can always put 1 plus, if you put ax as tan theta, 1 plus tan square theta is equal to sec square theta, under root sec square theta is sec theta. You can differentiate sec theta, you know already how to do that. Now we will do it by the traditional way, under root of anything. For example, under root t, the differentiation is 1 by twice of under root t, then whatever t is, we have to differentiate that. So this is going to be 1 by twice of under root 1 plus ax whole square, a square x square that is. Then 1 plus ax square differentiation. So a square x square, a square will be constant. And this will be 2x. So 2x a square it is. You can cancel 2 now. It will be a square x by under root 1 plus a x whole square or a square x square. Okay. So you have du by dx, you have dv by dx. Now in order to find out the final result, we have to find out du by dv. So I am taking that, dividing it now. A square x by 1 plus a square x square. So this 1a you can cancel here. So you have ax in the denominator. Okay, now this denominator, this goes up. When it is root, it is actually power half. So a 1 plus a square x square under root is a 1 plus a square x square half. Half comes down, it will be negative half. So the power is 1 power is 1, 1 power is minus half. So it will be 1 minus half, that is half. So it will be root under root 1 plus a square x square in the denominator. So I am writing under root 1 plus a square x square in the denominator. This is your final answer. Differentiate करना है this two. The difference is also given, that is the boundary also given. So we'll check the boundaries also. So we have seen question like this. We have done question like this. You know, without any problem, you can just write x equals to sine theta. So this is u, this is v. So du by dv you have to find out. Let us take this as u as sine inverse 2 sine theta under root 1 minus sine square theta. 1 minus sine square theta is cos square theta. Under root cos square theta is cos theta. So you are going to write cos theta here. 2 sine theta cos theta is sine 2 theta. And you have a sine inverse already. You can cancel sine and sine inverse. You will get 2 theta. So u is equal to 2 theta. Now you have to check also. Minus 1 by root 2 and 1 by root 2 is already given. So when you have x between negative 1 by root 2 and 1 by root 2, x is sine theta. So sine theta is between minus 1 by root 2 and 1 by root 2. So theta is equal to sine inverse of negative 1 by root 2 and 1 by root 2. So you have to take the sine inverse. And when you take the sine inverse, it is simply pi by 4 and minus pi by 4. See that theta is between minus pi by 4 and pi by 4. Now minus pi by 4 and pi by 4 is in the range of minus pi by 2 and pi by 2. So we have no problem here. Okay, so you have to multiply 2 also. Because you have to find out 2 theta. So when you multiply 2 theta, it will be negative pi by 2 and pi by 2, which is exactly the range which we wanted. Okay. So this is minus pi by 2, pi by 2. The range is also good. So now you can directly go ahead with the solution. From here you have theta as sine inverse x. Just write it as sine inverse x. Du by dx will be equal to 2. Sine inverse x is what? 1 by under root 1 minus x square. So 1 by under root 1 minus x square will be du by dx. This is the first thing you got. We have just done du by dx. Now the second part is to differentiate v. Okay. So let us differentiate the other part and then find out dv by dx. So v is equal to, in this case, I'm just giving some space because we are going to divide it in the final solution. So tan inverse, in place of x, what are you going to put? Again, same thing. So you have x as sine theta, under root 1 minus sine square theta. 1 minus sine square theta is cos square theta under root is cos theta. So you will get sine theta by cos theta. So you have sine theta by cos theta here. So tan inverse sine theta by cos theta. Okay. And sine theta by cos theta is nothing but tan theta. So tan inverse and tan theta gets cancelled. And when you cancel, when we were doing the checking, theta came. I told you it is between minus pi by 4 and pi by 4 if you remember. So this from here only you can tell, or you can do the checking again. So there is no problem. Theta you can write, it is sine inverse x from here. X is sine theta, so theta will be sine inverse x. So dv by dx will be equal to 1 by under root 1 minus x square. So du by dx, dv by dx, now you have to find out du by dv. Let us divide this. 1 by under root 1 minus x square. 1 minus x square, 1 minus x square under root cancels. Only 2 will remain. 2 is your answer. Okay. This is 2. Differentiate tan inverse 2x by 1 minus x square with respect to this. So this you can directly do. Okay. Since we have done a question like this, multiple questions we have done like this. So I will encourage you to do it by yourself. Just put x as tan theta in both the cases. And since there is a periphery or the boundary being given from 0 to 1, you have to check for 0 to 1 also. Okay, so you will get the same answer. The checking is important. Normally the students, they generally don't do the checking. But this checking 0 to 1 is given for you to show the examiner that, oh, I know that whatever I am doing is correct. Because sometimes theta may come, sometimes pi minus theta may come, sometimes pi by 2 minus theta may come. So the answer may vary differently. Here we have, what are we going to put x as what? Other things you already know. Now you see here, so u is equal to this one, v is equal to this one. So u is tan inverse x minus 1 by x plus 1. So x you can take it as tan theta. So theta is going to be equal to tan inverse x. Now theta is tan inverse x. So what are you going to get? So tan inverse, this is tan theta minus 1 divided by tan theta plus 1. So tan pi by 4 is what? 1. So in place of 1 I am writing tan pi by 4. Let me write it as tan pi by 4. And the denominator you have x. X is, again, I am writing it on this side, okay? So 1 plus x is tan pi by 4. Tan pi by 4 is 1. Tan theta was already there because it is x. Okay? So tan theta minus tan pi by 4 by 1 plus tan theta tan pi by 4. This whole is tan inverse tan theta minus pi by 4. Tan a minus b it is. So now you can just cancel these two out. You get theta minus pi by 4. Now this theta minus pi by 4 has to be checked between minus half and half. Please remember. Okay. So when you have x is between negative half and half, and when you put x as tan theta, we don't know the precise value here. From the table you can see that this, if you put 0.5, because half is 0.5 only. When you take tan inverse of half, you see where half will be. Between 1 and root 3. Root 3 is 1 and 1 by root 3. Because 1 by 1 and 1 by root 3, in between you will get 0.5. So when you take tan inverse negative half and tan inverse half, you will get a value between these. So there is no point we are going out of the bounds. So this is acceptable. This you can accept. Alright. So it is in the range. You can finally cancel tan and tan inverse wave, which we have already done. Okay. So this one more thing you have to do. Minus pi by 4 also you have to do. So tan inverse minus half minus pi by 4. When you do minus pi by 4, you have to minus. That is, you are actually when you are subtracting, it has to be subtracted from all the sides. So you have to write tan inverse minus pi by 4 minus pi by 4 on the left and minus pi by 4 on the right also. So theta minus pi by 4. So theta minus pi by 4, because you cannot check just theta. You have to check for theta minus pi by 4. You are cancelling tan and tan inverse when inside you have theta minus pi by 4. Okay. So from here it's quite clear. We can cancel them. Du by dx is going to be, this is going to be 0. Theta is your tan inverse x. So because x was tan theta when we started. So tan inverse x it is. Du by dx will be 1 by 1 plus x square. That is your final result for the u. So du by dx 1 by 1 plus x square. So let me clear this. Now we are coming to v. V is sine inverse 3x minus 4x cube. So x we are going to put as sine theta. Sine theta, this kind of variation or this error checking, or the not error checking, you can say bound checking, we have already done in the previous discussion. So I am just leaving it for you. V is equal to sine inverse 3 sine theta minus 4 sine cube theta. We have put x as sine theta. So this is sine 3 theta. This inside one is sine 3 theta. So you can directly write sine inverse sine 3 theta. So now you can cancel these two, sine and sine inverse. So V is equal to 3 theta here. So what is theta here? Sine inverse x. Okay. Theta is sine inverse x. So V is equal to 3 into sine inverse x. So when we do dV by dx, 3 will remain like that. And sine inverse x is 1 by under root 1 minus x square. Okay. dV by dx is this. du by dx we have already found. So we have to find out du by dx divided by dV by dx. Now in this question, there is a lot of trigonometry involved. Rather than solving it through the process of differentiation, first we have to make it simplified so that we can solve it. So this is u, this is v, and this cos x divided by 1 plus sin x, cos x divided by 1 plus sin x. So how are we going to write it first of all? Cos x, we know that cos 2x is cos square x minus sin square x. This formula you already know from trigonometry. So cos 2x is cos square x minus sin square x. When it is cos x, it will be cos square x by 2 minus sin square x by 2. So you have cos square x by 2 minus sin square x by 2. Now sin x can be written as 2 sin x by 2 cos x by 2, because sin 2x is 2 sin x cos x. 1 you can write it as sin square plus cos square x by 2, because sin square theta plus cos square theta is equal to 1 always. So you will write here cos square x by 2 plus sin square x by 2. Okay. This was 1 actually. Now the upper one is a square minus b square. So you have a minus b, a plus b. So cos x by 2 minus sin x by 2, cos x by 2 plus sin x by 2. In the numerator, a square minus b square is nothing but a minus b, a plus b. A minus b into a plus b. And denominator you have a plus b whole square. So you have sin x by 2 plus cos x by 2 whole square you can write. Alright. So this a plus b whole square and above one of them can be cancelled. So finally you get cos x by 2 minus sin x by 2 by cos x by 2 plus sin x by 2. Now divide numerator denominator by cos x by 2. Divide numerator denominator all by cos x by 2. I am just writing cos x by 2. Don't go deep into my handwriting. Just listen to me. So cos by cos is 1 minus sin by cos is tan. Again cos by cos is 1 plus sin by cos is 10. So you have 10x by 2 here. Okay. So in place of 1, we can write it as 10 pi by 4 because we know 1 is 10 pi by 4. It is tan 45 degree. So 10 pi by 4 minus 10x by 2 divided by this 1 can be written as again 1 plus 1 into 10 x by 2. So it can be written as 10 pi by 4 into 10x by 2. Now 10a minus 10b by 1 plus 10a 10b. It is 10a minus b, 10 pi by 4 minus x by 2. Okay. So we started from here. Tan inverse of inside cos x by 1 plus sin x. So tan and tan inverse you can cancel. U is finally pi by 4 minus x by 2. When you try to find out du by dx, what do you get? Pi by 4 is 0 only. Minus x by 2. And differentiation of x is 1. So minus half is du by dx. How about sec inverse x? dv by dx. So we have v as sec inverse x. When you take the differentiation of sec inverse x, it will be 1 by x into under root x square minus 1. Okay. This is a result which is a general result. du by dx, dv by dx you have to find out. So you have minus half here divided by this one. So this goes up. So you can just write x under root x square minus 1. Negative is already there. 2 is in the denominator. That is your final result. This is your final answer of this question. Minus 1 and 1. So sin inverse 2x by 1 plus x square, tan inverse 2x by 1 minus x square. So this type of questions we have taken a lot in our discussions. X is tan theta. You can put theta as tan inverse x. Here also there is a range minus 1 to 1 given, and that will be inside a minus pi by 2 and pi by 2. So you don't have to worry about that. And this question, since it is just a repetition and you already know the answer is going to come as 1, because both the time you are going to get 2 tan inverse x. And that 2 tan inverse x differentiation, even if we take differentiation without differentiation also, it's going to divide completely. So it is going to be 1. The answer is 1. Alright, I am skipping it now. So this question, cos inverse 4x cube minus 3x with respect to tan inverse this, half and 1 is the range. So in place of x, just write cos theta. So this is u, this is v. So x is cos theta. So theta is equal to cos inverse. So cos inverse 4 cos cube theta minus 3 cos theta. And theta is equal to cos inverse x. 4 cos cube theta minus 3 cos theta. So this formula is nothing but cos 3 theta. That is standard result. So don't worry about that. Theta, you can cancel 3 theta. U is equal to 3 theta. Du by dx, when you find out, it will be going to be theta. You have to change to x. So it will be cos inverse x here. And cos inverse x differentiation, you know already. You have been doing it, entire life. So it is going to be 3 minus 1 by under root 1 minus x square. Now when we do this, we have to check the boundary also. So this cos inverse x differentiation is what? Negative 3 by under root 1 minus x square. Okay. This is your standard result. Now coming to if you want to check, then you already know how to check. That you can, x is between half and 1. Okay. So we have taken it as cos theta. It is between half and 1. So theta is going to be equal to cos inverse half and cos inverse 1. So cos inverse half, cos inverse 1, it will be theta between these. So you know already this. Okay, one is 60 degree, one is 0, because cos inverse 1 is 0. Cos inverse half is pi by 3. So when you are between 0 and pi by 3, and you have to find out for 3 theta, remember, you just multiply it by 3. So this is a check that you can verify. So whenever you verify this, you are quite sure that the way you are adopting in this range, the solution half and 1, the approach is correct. So what do you get? From 3 theta from pi and 0. So this is in the range which we have no problem. Okay, first differentiation we have already done. The second part is tan inverse under root 1 minus x square by x. So v is equal to tan inverse. In place of x you can write cos theta. So it is going to be 1 minus cos square theta divided by cos theta. 1 minus cos square theta is sin square theta. Under root of sin square theta is sin theta. Sin theta by cos theta is tan theta. So it will be just tan theta. Tan theta. Theta we have already checked between pi by 3 and 0. We have no problem. We already checked. Okay. This already done. So we can directly go ahead with the solution now. V is theta now. Theta is nothing but cos inverse x. So just write cos inverse x. And differentiation of cos inverse is x is minus 1 by under root 1 minus x square. So when you do du by dx divided by dv by dx, it is 3 by minus 3 by under root 1 minus x square, and divided by 1 by minus 1 by under root 1 minus x square. You can cancel these, minus minus gets cancelled, you get a 3. Okay. Differentiate. So u and v, it's given to you. So x equals to sine theta we are going to put. This is u, this is v. Okay. And there is a periphery also. Boundary minus 1 by root 2 to x. 1 by root 2 x should lie between these two. So u is this one, tan inverse. In place of x, we are going to replace it with sine theta. So theta will be equal to sine inverse x. So u is equal to tan inverse. In place of x, write sine theta divided by under root 1 minus sine square theta. 1 minus sine square theta is cos square theta. Under root of cos square theta is cos theta. Sine theta by cos theta is tan theta. So tan inverse tan theta. Tan and tan inverse you can cancel. And this is theta. We'll talk about this minus 1 by root 2 and 1 by root 2. Okay. So this is the range. Let me write it here. Because x is between these two, right? So in place of x, what you are going to place? Sine theta. Sine theta is between this one, minus 1 by root 2 to 1 by root 2. Alright? So this is, you can take sine inverse, all of it. So this theta will be equal to sine inverse minus 1 by root 2, sine inverse 1 by root 2. So this is minus pi by 4, this is pi by 4. Minus pi by 4, this is in this range. Okay. So this theta is equal to sine inverse x. Theta is sine inverse x. And du by dx is equal to 1 by under root 1 minus x square. This is your du by dx. Coming to v. V is sine inverse. What you have to put? X is sine theta only. So theta will be sine inverse x. Now let us replace it now. Sine inverse 2 sine theta under root 1 minus sine square theta. 1 minus sine square theta is cos square theta. Under root of cos square theta is cos theta. 2 sine theta cos theta. So it is sine 2 theta. Sine inverse sine 2 theta. Now you can just cancel this sine inverse and sine. If you make it as 2 theta, it will be minus pi by 2 and pi by 2. That is in our range. Okay. So this gets cancelled. You have 2 theta. 2 theta is from here. It's sine inverse x. So it is twice of sine inverse x. dv by dx is equal to twice of 1 by under root 1 minus x square. du by dx divided by dv by dx. So what are you going to get? 2 by under root 1 minus x square. This gets cancelled. You will get 1 by 2. Okay. This is your answer. Sine inverse under root 1 minus x square with respect to cot inverse x by under root 1 minus x square. X is between 0 and 1. So you have to check for this range 0 and 1 whenever we replace x by something. Okay. So x is equal to cos theta. Theta is cos inverse x. So we have sine inverse under root 1 minus x square. This is u, this is v. Let us do v first. So we have cot inverse x is cos theta divided by under root 1 minus cos square theta. 1 minus cos square theta is sin square theta. Under root sin square theta is sin theta. So we have cos theta by sin theta, which is actually cot theta. So I am replacing this under root 1 minus cos square theta as sin theta. Cos theta by sin theta is cot theta. So cot inverse cot theta we got. So this is only theta. Cot inverse cancel. So checking, I hope you will be able to do. Okay. This we have done many times. So dv by dx is theta. You have to write cos inverse x. Cos inverse x is minus 1 by under root 1 minus x square. U is, this is sine inverse under root 1 minus x square. So 1 minus cos square theta. 1 minus cos square theta is sin square theta. Under root of sin square theta is sin theta. Right? So this you can cancel. Theta is what? Cos inverse x. And du by dx will be same as dv by dx. Du by dx and dv by dx will come same because both are cos inverse x minus 1 by under root 1 minus x square. So these two are exactly similar. When we divide this, dv by dx divided by du by dx is going to be what? It is 1 because both are same. So this is your answer, right? Now this x is between 0 and 1. So when you take this as cos theta, it is between 0 and 1. So theta will be cos inverse of these two. Cos inverse 0, cos inverse 1, cos 0 is 1, cos pi by 2 is 0. So you can write it as pi by 2. This theta is between your pi by 2 and 0 in between. And when it is between 0 and pi by 2, the boundary is actually minus pi by 2 and pi by 2. So you're getting this inside it. Okay. So this is your 1. Differentiate sine inverse with this one. So wherever we get a square x square, we will, because it is already given in the question, ax is between minus 1 by root 2 and 1 by root 2. The question is only saying you have to put ax as something, right? So ax we will put as sine theta. And the range is also given minus 1 by root 2 and 1 by root 2. So we have been doing sine theta range between this negative 1 by root 2 and 1 by root 2. You know how to check this. Ax, we are keeping it as what? We are putting it as sine theta. So theta will be sine inverse of ax. So sine inverse ax, we'll talk about this later. U is sine inverse. And this is 2ax under root 1 minus a square x square. So this twice of ax. So it will be 2. Ax is sine theta under root 1 minus sine square theta. So under root 1 minus sine square theta. 1 minus sine square theta is cos square theta. Under root cos square theta is cos theta. So I am just replacing it by cos theta. 2 sin theta cos theta is sin 2 theta. So sin inverse sin 2 theta. U is this. You can cancel this. U is 2 theta. And the range you already know how to check it. But let us solve this. Du by dx is 2. Theta is what? Theta is sin inverse ax. So you have 2. Sin inverse ax is 1 by under root 1 minus a square x square. Then the differentiation of ax. Differentiation of ax is what? It will be, because x will be 1, so it will be only a. Okay. This is your du by dx. Now let us see this dv by dx. And before that we need to check the range also, because it has to be between the valid boundaries when we cancel this sin inverse or cos inverse or tan inverse. So there is no point in replacing anything here. It is under root 1 minus ax whole square. So 1 by twice of this d by dx, 1 by twice of 1 minus ax whole square or a square x square. Then 1 minus a square x square differentiation. So it is 0 and this is 2ax and then x. So ax is a. So you get minus 2a square x. So let us write it here. What I am trying to suggest here is, even if you do 1 minus a square x square, it is going to be equal to x square is 2x. So you will get here, this 2 and 2 I am cancelling. This 2 and 2 I am cancelling here, putting it here and then cancelling, okay. So 2 you can cancel. It will be a square x divided by under root 1 minus a square x square. So this is dv by dx. You need du by dx divided by dv by dx. Okay. Now just divide these two. So just I'm keeping it or placing it in the denominator. So you have this only minus 2 by ax will remain. Minus 2 by ax. See, under root 1 minus a square by x square, so they are similar, so it will get cancelled. Minus 2a by a square x, 1a gets cancelled, minus 2 by ax. This is du by dv. Now let us check this ax, it's minus 1 by root 2 and 1 by root 2. Ax is sine theta. Sine theta is between minus 1 by root 2 and 1 by root 2. And theta is equal to sine inverse of these. Sine inverse of this. Okay. So this sine you can write just minus pi by 4 and pi by 4 theta is between these two. And this is between the range. You have, even if you do twice of theta, because twice of theta is there, u equals twice of theta. It will be minus pi by 2 and pi by 2, which is well in our range and we can go about it. Okay. Let us differentiate tan inverse 1 minus x by 1 plus x with respect to under root 1 minus x square. Minus 1 to 1, the x is in between these two. Okay. So this type of question I think we have already done, but I'll give you a basic here. This is just a recalling or refreshing. X you have to put as tan theta. So let us put x as tan theta. Theta will be equal to tan inverse x. So you will get tan inverse 1 minus tan theta divided by 1 plus tan theta. So 1 you can write pi by 4, tan pi by 4, because tan pi by 4 is, or tan 45 degrees 1. So tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 tan theta. Tan pi by 4, as I just indicated, is 1. So this becomes tan a minus b, tan pi by 4 minus theta, and tan inverse is already there. You can just cancel these two. So u is this. So du by dx, this pi by 4 is 0 minus theta. So minus theta basically it will come. And theta is tan inverse x, or negative tan inverse x it will come. Tan inverse x is 1 by 1 plus x square, negative is also there. So du by dx. Okay. Then we have this dv by dx. So x is between minus 1 and 1. So x is tan theta. And this is minus 1 and 1. Okay, just remember, we just don't have to check theta here. We have to check for theta minus pi by 4 minus theta. So pi by 4 minus theta, in order to do that, first you have to multiply everything by negative 1. So whenever we multiply by negative 1, the inequality will change. So when the inequality will change, this because we are multiplying it by a negative value, then you need to add pi by 4. Okay. So this is pi by 4. You need to add pi by 4 plus pi by 4 is pi by 2. Pi by 4 minus pi by 4 is going to be 0. So pi by 4 minus theta is between, because the inequality already changed. So it has to be between 0 and pi by 2. Means 0 and 90 degree. Alright. So du by dx, now dv by dx. So v is under root 1 minus x square. dv by dx is what? 1 by twice of under root 1 minus x square. 1 minus x square. This is 0. This is 2x minus 2x. So we write minus 2x. 2 gets cancelled. minus x by under root 1 minus x square. Okay, just keep it here, minus x divided by 1 under root 1 minus x square. So there is no cancellation possible. Only negative will cancel. Minus minus will cancel. Rest thing will remain same. Okay, that is final will be under root 1 minus x square divided by x into 1 plus x square. This is going to be your final result. Alright. Okay, this is all about this exercise. Thank you so much and take care of yourself.